Everybody, we have this question. We expected to integrate this question. I think there should be okay. So foremost, what I wish to do is this is x raised to the power of 3m added with x raised to the power of 2m added with x raised to the power of m. I'm going to multiply by a x for this term, 2 times x raised to the power of 2m, positive 3 times x raised to the power of m, positive 6. This is raised to the power of 1 over m, and I'm going to divide by x. Now, if you have, say, something x raised to the power of 4, and you raise it to the power of 1 over 2, this can be rewritten as x squared, right? Now, x squared, if it has to go in, then this x squared is rewritten as x raised to the power of 4 because of the fact that you have 1 over 2 there as a index. Similarly, what I wish to do here is I would like to pull in this x inside. Now, if I were to pull this x inside, this x will now be x raised to the power of m, okay? And because of the fact that I got 1 over m as an index. So, having mentioned you this, let me rewrite this as x raised to the power of m raised to the power of 1 over m, which is nothing but x. That's the intermediate step, followed by 2 times x raised to the power of m, positive 3 times x raised to the power of m, positive 6. This is raised to the power of 1 over m, and you have a dx there, divided by x. Now, this has got x raised to the power of 3m, positive x raised to the power of 2m, positive x raised to the power of m. Now, this is equal to, as I mentioned to you, I would like to pull this inside. Now, if I were to pull this inside, then 2 times x raised to the power of 2m will be actually multiplied with x raised to the power of m, because of the fact that I am actually taking x raised to the power of m common, and that is raised to the power of 1 over m. So this is followed by 3 times x raised to the power of m times x raised to the power of m, positive 6 times x raised to the power of m. The entire component is raised to the power of 1 over m, and this is divided by x, and you have a dx there. And this is equal to x raised to the power of 3m, positive x raised to the power of 2m, positive x raised to the power of m. Now, a raised to the power of n times a raised to the power of m is a raised to the power of n positive m, and a raised to the power of n multiplied with a raised to the power of n is a raised to the power of 2n. So, by this property, I can add x raised to the power of 2m with this m. So this is going to be equal to, let me write this down here, 2 times x raised to the power of 3m, positive 3 times x raised to the power of 2m, positive 6 times x raised to the power of m. This is raised to the power of 1 over m multiplied with dx divided by x, and you have x raised to the power of 3m, positive x raised to the power of 2m, positive x raised to the power of m. You have an integral sign. Now, I would like to actually shuffle these two things out. So the meaning is, in place of this I would place this, in place of this I would bring this in. So this is equal to integral 2 times x raised to the power of 3m, positive 3 times x raised to the power of 2m, positive 6 times x raised to the power of m. This is raised to the power of 1 over m multiplied with x raised to the power of 3m, positive x raised to the power of 2m, positive x raised to the power of m, divided by x times the dx. Now you can take this to the numerator, that will become x raised to the power of m negative 1 multiplied with x raised to the power of 3m, positive x raised to the power of 2m, positive x raised to the power of m times the dx. This is equal to 2 times x raised to the power of 3m, positive 3 times x raised to the power of 2m, positive 6 times x raised to the power of m. This is raised to the power of 1 over m. Now, as I mentioned to you, by the same property, I can move this x raised to the power of negative 1 inside. That one would give me x raised to the power of 3m, negative 1, positive x raised to the power of 2m, negative 1, positive x raised to the power of m, negative 1, multiplied with dx, and you have 2 times x raised to the power of 3m, positive 3 times x raised to the power of 2m, positive 6 times x raised to the power of m, raised to the power of 1 over m. Now what I wish to do is, I would like to make the following substitution. Now I hope you have this. Let me move on to this substitution. Let me just let 2 times x raised to the power of 3m, positive 3 times x raised to the power of 2m, positive 6 times x raised to the power of m is equal to sum u. So you differentiate this. If you differentiate this, you have 2 times 3 times m times x raised to the power of 3m negative 1, positive 3 times 2 times m x raised to the power of 2m negative 1, positive 6 times m times x raised to the power of m negative 1, multiplied with dx is equal to du. This is what you got. You rewrite this. If you have to rewrite this, this is equal to 6 times m x raised to the power of 3m negative 1, positive 6 times m x raised to the power of 2m negative 1, positive 6 times m x raised to the power of m negative 1, multiplied with dx is equal to du. Now you can take 6m out. This will be x raised to the power of 3m negative 1, positive x raised to the power of 2m negative 1, positive x raised to the power of m negative 1 times the dx is equal to du. Now move the 6m down. So this is x raised to the power of 3m negative 1, positive x raised to the power of 2m negative 1, positive x raised to the power of m negative 1 times the dx is equal to du divided by 6m. So go back to the step that we had obtained. Now in place of this, I can substitute this. Okay, and in place of this, I will substitute u. So this is equal to u times and raised to the power of 1 over m, right? Because this only is taken to be as u. This is raised to the power of 1 over m times dx over, or I would say du over 6m. So this is equal to 1 over 6m times u raised to the power of 1 over m times du. Now this is similar to x raised to the power of n dx, which is nothing but x raised to the power of n positive 1 divided by n positive 1 positive c. So this will give us 1 over 6m u raised to the power of 1 over m positive 1 divided by 1 over m positive 1, which can be rewritten as 1 over 6m times u raised to the power of m positive 1 divided by m positive 1 divided by m. So you flip it, these two m's goes away, giving you 1 over 6 times m positive 1 times u raised to the power of m positive 1 divided by m. But my u, what is my u? My u is equal to, go back here, this is my u, right? So write that u is equal to 2 times x raised to the power of 3m, positive 3 times x raised to the power of 2m, positive 6 times x raised to the power of m. So that would mean you have 1 over 6 times of m positive 1 times u is 2 times x raised to the power of 3m, positive 3 times x raised to the power of 2m, positive 6 times x raised to the power of m. This is raised to the power of m positive 1 divided by m, positive arbitrary constancy. So this is the solution for this question. Thank you.